Hello, hello. Is audio and video is visible to everyone? Hello, hello. Is audio and video is visible to everyone? I hope it is. Hello, hello. So yeah, in the morning session, if you are remember, we have seen a very important thing, that is a motion in a straight line, and we have seen about the two important things, that is, uh, first thing, we have seen about the different terminologies, and we have seen the some basic formulas also. That this is a problem always came. Just give me 1 minute. This problem always arises. Wait a minute. So we have seen few terminologies, and we have also seen a lot of another things. Okay. Wait a minute. Not be okay. Wait. What is the problem? Mathematical tool, straight line in motion. Okay. So it is open. Just wait for a minute. So yeah, we have discussed about the different terminologies. We have seen the graphs. We have seen the equations. In today's this session, we are going to cover the motion and the gravity. This is a very small topic, and then this session will be finished. In tomorrow's morning session, we are going to either we will going to start a new chapter, if I will see according to that, and then we will, otherwise we will do some numericals on these two topics which we have covered. That is, first is the mathematical tools, and second we have covered is the motion in a straight line. We will solve some previous year questions so that you will get confident on that, because you should know what I am teaching is going to become in your exam or not. So I will tell you, I will show you how to apply it, and then we are going to start a next chapter. Clear? So this is that is why we have designed this course in such a manner, so that you will get the practice as well as all the theory aspect which is required for your preparation. Clear? So let us start. So in the morning session, if you remember, we have completed till here, like how to see the slope, a general idea. Now our next topic, I told you, that is going to be the motion under gravity. Okay, motion under gravity means how the particle move. It is a very small session. First of all, it's not going to be very big session. So motion under gravity, that is why I started this session little late. So the first thing is that, because my health is also not good, so yeah, first of all, if we are talking about a motion under gravity, then here the acceleration will be, what is the acceleration? The acceleration is fixed. Which is g. Acceleration is fixed, that is g. And this value will be either 9.8 meter per second you can take, or sometime you take 10 meter per second minus 2. These are the two general values we used to take for solving the question. That is the first thing. and remember g is a constant. G is a constant. So if my acceleration is constant, what are the equations we have? Then we can directly apply it as acceleration is constant, as acceleration is constant. So if acceleration is constant, I can directly apply those equations. What are those equations? First equation, we can apply the equations of motion. Okay, we can apply the equations of motion, correct? And what are those equations of motion? That is, first is, we know that equations. Okay, we have seen this equation, so just now I'm not going to repeat that. We know that equations, by the way. Okay, first things, that is the second. Now there are that let us see about it in more detail. uh, See, we can take, like, there are the two types of cases are there. First case, let's take, how I can name it, ground to ground motion. We can name it like this, ground to ground motion. Okay, let us talk about ground to ground motion. What I am trying to say, first of all, understand. See, suppose, let us consider some particle is falling from the top. Okay, this is my height h. This height is, suppose this height is h. Okay, and it is falling from the top, correct? It is falling from here. Suppose, my question is very simple. What you understand? Like, suppose I throw the ball like this and it is coming like this, correct? So what I am trying to say, if here suppose the velocity which you have given here is 2 meter per second, okay, when it will come at the same stage, when it will come down also, it has the same velocity of 2 meter per second. That is the first thing to observe. Second thing to observe, here also the acceleration is downward, that is minus g. Here also the acceleration is downward, that is minus g. In all the motion, the acceleration is always downward. There is, but in this case it will act as an acceleration. Why? Because the velocity and acceleration have a same direction, and in this case it is a retardation. It is a retardation. It is a retardation, correct? Now third important point. Here it is a plus v positive. So basically we can say upward direction we are taking as positive and downward direction we are taking as negative. That is a common logic. So at an instant, if suppose like this is the case, you understand or not? Is it clear to you? Okay. Okay. Suppose I considered just remove this case, okay? Just for now, just remove this case. Have you understand this or not? What I am trying to explain from here, is that okay for you or not? Just remove that. We will cover this. I will cover this in the letter. Like, I want to take it in a smooth so that you can understand first. First, you have to understand, if it is a motion under gravity, that means my acceleration is fixed and the acceleration is equal to g, that is 9.8 meter per second square, or you can say 10 meter per second square, and it is a constant, so that it is a motion under the uniform acceleration. That is a concept. Second thing is that If suppose I am taking a particle and throwing it upward direction, the path will be like this. What we are seeing that here we have a retardation and here we have a acceleration, and also at this instant whatever the velocity, the same velocity is present at this instant also. That is the first thing we have observed. Clear? First thing, that is the first thing we got to know. Clear? I hope this much is clear to you. Please note it down. If this is clear, please note it down. Completed? Okay. Next thing. Just I want to take a few cases so that I want to explain you a few important things. Generally it is not required, but let me explain you so that you can directly solve any question. Okay. Because try to understand, suppose the height at this is x equal to 0 and this is x equal to h, means this height is what? This height is h. What I am trying to say, this height is h. Okay. First thing, I have thrown a ball like this with the initial, I just dropped it, initial velocity is 0, it will come down. My question is how much? First question is my very simple, what is time of flight? Time of flight, that is the first question. See what I know initial velocity is 0, correct? What is another thing I know? Another thing, when it will come down, that I know. Another thing I know, that is displacement is minus h. See, we are going from here to here, so displacement is minus h. What is the acceleration? Acceleration is equal to minus g, because it is acting downward direction. Anything else we don't know. What is the equation which will be most suitable? S is equal to ut plus half at square, correct? S is minus h, u is 0, half a is minus g into t square. So from here you get time of flight is root over of 2h by g. You can see the time of flight does not depend upon the mass of the object. It doesn't matter what is the mass, it will be always same. Independent of mass, correct? Second thing, when it will reach the ground, what is the velocity at x is equal to capital H? When it will reach the ground, what is the velocity here? If you see, there are the two methods to solve it. First method, let me tell you. See, first thing we know, that is we have an equation v square is equal to u square plus 2as. Now everything we know, we want to, this thing term is 0, correct? We want to know v, so v is equal to root over of 2gh, correct? That is a direct, from this there we have get. There is another approach is also there, another approach. What is the another approach? If you see another method, you can see another method. What is the another method? If you see what is the initial potential energy here, if you know about potential energy, what is the potential energy of this object at this point? Suppose the mass is m. Suppose the mass is m. Okay, what is the initial potential energy? That is mgh, potential energy. And finally it will come to ground. So what is the final energy will become? Kinetic energy, half mv square. So potential energy is converted into kinetic energy. Mm will cancel out, you will get v is equal to root over of 2gh. See, you are getting the same answer from here also, from here also. So that is what I am trying to tell you. Okay, it doesn't matter, you will get the same answer. This is from energy conservation approach, correct? Any doubt? One more thing, observation. One observation I tell you, I would like to tell you. Observation is very simple. See, S is equal to, we know, half gt square, correct? So I can say my S is directly proportional to t square. Are you getting my point? So if t is equal to, S is directly proportional to t square, that means if I ask you S1, S2, S3, S4, then the distance traveled in this will be in the ratio of 1:4:9:16. That means in 1 second, if I talking about 1 second, what is the distance travel? That is x. In 2 seconds, what is the distance travel? What is the distance travel in 2 seconds? That is 4x. In 3 seconds, what is the distance travel? That is 9x. Are you getting my point? So that is the thing what I am trying to explain you. So that here the distance travel is directly proportional to the time interval. at what time interval you are talking about. Okay, so that is a one approach you can understand from here. Okay, that is the observation. If you understand, that is better. If you don't understand, that is also better. Okay, because if you understand the thing, that is very better. If you don't understand, that is also better, because generally it's a short trick. It just used to make the question solving easier. But if you don't understand, no problem, we can solve the question. If you know the basics, na, you know these equations, you can solve. There is no need that you should know all the short tricks and everything. That is not required. Your basics should be strong. That is the only thing. Now if I ask you to draw few graphs, can you draw? Yes, you can draw the few graphs. Simple thing, suppose I have a time and I have a x. So with the distance, and I have to draw the graph. This is my distance, or you can say displacement versus time. If you draw the graph between displacement versus time, you will get the graph like this. Okay, initially the height is h, when it will reach the ground, that height will become 0. Clear? Next graph I can ask you to draw. Next, which graph I can ask you to draw? Next graph, okay. Next graph is, that is minus g, acceleration versus time. So acceleration is always minus g, which is very much clear. Okay, and another graph we can draw. If I ask you velocity time graph, yes, what is the velocity time graph? What is the velocity time graph? Tell me, what is the velocity time graph? Velocity time graph will be something like this, correct? So these are the some important graphs you can draw in the motion under the gravity. These are the some important graphs. Clear? Any doubt? Any doubt is there? Okay, let's take some other important points. Let us consider one special case. Suppose this is my height h, okay, this height is h, and suppose from this height I have thrown a ball and it will come like this, correct? It will come like this. I have thrown it with a velocity u, correct? Now as you can see, it reached some height. My first question is that what is that height? If you calculate it, you will get this value as u square by 2g. Okay, that height is u square by 2g, correct? Second question is that what is that v? The v will be equal to u square plus 2gh, correct? Third question, maximum height. What is the maximum height? This height is u square by 2g plus capital H. That is the maximum height. Okay, and the last thing is that time of flight. Okay, remember it is a total. I am asking for total. So total time of flight is fixed. How to calculate? See, we have a formula, h is equal to ut minus half gt square. From there you can directly calculate what is my time of flight. Simple. Okay, remember it is minus h, okay, because height is downward, so minus h ut minus half gt square. From here you will get the two values of t. One is positive, one is negative. You have to take the positive value. No need to take the negative value. There is a reason. There is a meaning of that negative t also. But for now, don't go into that logic. Just please don't consider the negative values. Clear? So this is the one of the case. Second, some extra case you can say, like bouncing case. Okay, like suppose I have I have thrown a ball. Okay, it's come down, then it's a collide, and then again go up, then again come down, then again go up, like that. Okay, means the collision, there is a collision. Okay, there is a collision, it is happening. Okay, it is a collision is happening. If it is coming with u velocity, it is going with u velocity above. If it is coming with u velocity, it is going above with, means elastic collision is there. Elastic collision, it is happening there. In this case, my first question is that, which everyone will ask, that is, what is the displacement versus time graph? Because velocity is fixed now, velocity only direction is changing. What is the displacement versus time graph? So if you see, the displacement versus time graph will be something like this. Okay, it will be something like this. It is displacement versus time graph, correct? X versus t. Correct. Second graph. Second graph, if I ask you, that is, in this case only, what is the velocity versus time graph? You can see the first velocity is, you can clearly see, first the velocity is decreasing, then directly it will become positive, then it will start decreasing, then it will become positive, like this. Okay, and the last graph, okay, that is the acceleration versus time graph. So in all the cases, if you see, what is the acceleration? So acceleration is again minus g only. Okay, acceleration direction is not changing. First of all, let me make very clear to you, that is acceleration direction not change. Okay, acceleration direction is always fixed, minus g. So these are for this case, for this case. Okay, for this case we have drawn the graphs. Clear? Okay, please note it down. Okay, now one important case. Okay, with v velocity I am throwing a object and the height is h, and suppose the time is taken is t1, correct? Second case, what I am doing, I am taking us, second case, what I am doing, see here, just u velocity I am throwing it. Okay, and third case, what I am saying, second case, this is t2, this is t2, t3. It is a case, here we have considering two cases, either we have dropped with u equal to 0, or throw horizontally. Okay, and the height time t3. So what is the relation? Remember that the time t3 will be equal to root over of t1 into t2. That is a very important relation, and that is the extra point I have given to you. Remember that t3 is equal to t1 into t2, under root of t1 into t2. So this is what we have covered in motion in a straight line, and our motion in a straight line is completed. In the morning session, tomorrow's morning session, we are going to practice the numericals on this, and we are going to start the new topic in the tomorrow's evening session. Till then, if you have enjoyed this course, please share to everyone and have a nice day. Thank you.